Hello, welcome back to the video lecture series for Introduction to Data Programming using Scala. In this video, we're going to do another example using regular expressions. We're going to look at parsing a polynomial. This example is actually kind of born from a problem that was used in an ACM regional programming competition, and they gave you polynomials in a text form, and you had to do some operations with them. But in order to do that, the first thing that you had to do was to get them into a form other than the simple text. So let's go ahead and let's create a new, I'm just going to go with the Scala object. I'm going to put a main in here. Give us something that we can run. And we'll call this Regex poly. Not ploy, poly. We'll see how many times I do that typo today. Okay, so first let's talk about the format of what we're getting here. We are going to get strings, and they might look something like 3x to the 2 minus 5x plus 4. Okay. The general format is if the power is greater than, and so you have x raised to some power, it can be 1 or 0. If it's 1 or 0, so if it's 0, there's no x at all. If it's 1, there's no caret. If it's bigger than 1, there's a caret. The coefficient in front may or may not be there, with the exception here. So this could also be x cubed plus that, or this could be minus x to the 4th minus. Okay, so note that there are lots of possibilities here, and that's why the regular expression potentially makes this easier. And what I want to do is I want to parse these into a case class called a term as a coefficient that's an int, and the power that we're raising x to, that's also an int. And so what I just want to do here is I want to build this regular expression that can parse this for us. And literally what it's supposed to do is it is supposed to match one term at a time. Okay. So val poly regex equals, and we're going to make a regular expression here using our raw string. So we start off, there can be a plus or a minus, but not not both, and it's optional. Okay, I'm not going to allow the situation where we do plus minus like that. That was not part of the allowed inputs for this problem, and I generally will tend to agree with that. If there's a minus coefficient, if there's a negative coefficient, it'll just be minus that term. So we need to start, there could be a plus or a minus, but it is optional, and the reason it's optional is because if the first term is positive, there is neither a plus nor a minus there. Second, after that, we have the coefficient, which once again might not be there. So \d star. Then we have an x, or maybe we don't have an x. And this is one of these places where it turns out there is nothing in this format that you're guaranteed to have. You're not guaranteed to have the caret, you're not guaranteed to have the x, you're not guaranteed to have the coefficient in front either. So nothing is required. And if I build a single regular expression that does this, is just one thing with stars and question marks, it will have the ability to match the empty string, which I don't want to do. So I'm going to go ahead and put in here an alternative. Okay, so the thing to the left side of my pipe, my OR, is going to be all possibilities that include the x. And the thing that's on the right side is the one case here that does not include the x. That way I can actually put an x on the regular expression here and not have a question mark. If I tried to blend these together, this x has a question mark too, in which case you can have nothing here, nothing for the x, and then nothing for what's about to follow. I'm going to put in a set of parentheses. I've actually been avoiding parentheses. We're going to put in a lot more parentheses here for capture groups. But I first want to kind of build this regular expression, and we can do a little test to make sure that it works, and then we'll have to try to pull the data out of it. So next is something that's optional in that I have a caret followed by one or more digits, and as I said, that's optional. If you have the caret, you definitely have at least one digit after it, and that gives you the power that you're raising to. And so what would be nice to do here, in fact we can cut that and paste it here, val poly equals that, for s in poly regex dot find all in poly. Quick note, in the previous video I had been searching, the API tells us that there is a method in here called find all match in, and it's not popping up. Realize that the reason for this is because I'm using 2.9 and the regex is the most recent version of Scala, which right now is 2.10. So if you happen to have 2.10 installed on your Eclipse, you will have a find all match in. I'll show you in just a minute how we can get around that in 2.9. So I just want to run this where I print out the things that are matched and make sure that we find all of the terms appropriately. So I hit run, and here we go. Well, that's not quite what I wanted. X caret 4. Oh, I know why. Let's see, caret is a special. Let's try that again. There we go. Okay. Caret is special. Everything that is used in building your regular expressions has, is kind of a special character, and you need to escape them. And so the caret is definitely a special character because it is used to denote the either the not when it's inside of a character class, or it's used to denote that you're matching at the beginning of a string. So we have to escape it. So I got x to the 4 minus x to the 3 plus 3x raised to the 2 minus 5x and 4, which are exactly the terms that I wanted. So at least on this little test, my regular expression here is finding what I want. Now, I want to be able to pull the values out of here so that what I can do is put a val up there. Instead of just printing these things, I want to yield the appropriate terms, and then I want to print out those terms to make sure that they're appropriate. So I should get 1 and 4, minus 1 and 3, 3 and 2, minus 5 and 1, 4 and 0. Should be my coefficients and powers when we print this out. So this is supposed to do a new, or it's a case class, so I don't need the new, of something in here. Coef, comma, power, val, coef equals, well, just to make this compile, I could do that, and now I get a whole bunch of 1-1s, which of course is not the answer that I want. Okay, so how am I going to, I have matches here, this gave me back strings, but I can use a regular expression to pull things apart. Using 2.9, Turns out that this gives us back what's called a match iterator. And the match iterator has a method in it called match data, which gives you an iterator of matches. So instead of in 2.9, instead of calling the find all match in, you call find all in and then call match data on that. It's a little extra step. But now that gives us back an iterator over this match type. And the match type has inside of it things that will give you back information for groups. So this is where we're going to start inserting some more parentheses, and we're going to build groups around all the things that we want to be able to find. So for example, I want that to be one group. Okay, this is the coefficient at the front. Whatever this matches, I should be able to so that's a possibility for the coefficient at the front. That's a possibility for the coefficient at the front. And so if I have an x in the expression, this will be, it could be a blank here. It could be a minus sign here. Actually, there's part of me that almost feels, oh, hey, look at this. I probably need plus minus. Boom. If I had made this for a minus sign, we would have dropped out the minus previously. Okay, so that's going to, the constant part will either wind up being located in that group or in that group. The x, it turns out I don't need to capture because which group has values in it tells me whether or not there's an x. I also don't really care about the caret, because it's either there or it's not. So I want to just have a capture group around this. Now remember, our capture groups start numbering at 1, and they are numbered by the location of the open parentheses. So 1, 2, 3, 4. So 4 capture groups. The power is actually fairly easy here. It would be s dot group of 3, with one exception, or actually I guess 2 possible exceptions. Yeah, so everything will have it if it is a 2 or larger. The groups, if nothing was matched, come out as null. So both of these last terms will have the group be null. I think what I'm going to do here is change this up a little bit. Coef, comma, power equals, and I want to break this into 2 broad categories. One is the category where s dot group of 4 is null. Okay. Home, close, else, open. Okay. So if s dot group, and it's unhappy with me because I'm not returning a tuple yet. If 4 is null, that means that this didn't match and I have an x. Okay. In the case where I don't have an x, this is actually the easier case. If I don't have an x, I want the coefficient to be equal to s dot group of 4 dot 2int, and then the polynomial, or the power that I'm raising to, is 0. That's the easy case. Okay. What about the other case? Well, in the other case, my possibilities, I have lots of possibilities for what can go inside of here, but I know that the power is going to be at least 1, and I'm going to have some coefficient in here. There's a part of me, that would redo my numbers. That's okay. So val p equals, I'm going to deal with just this part here. So it turns out that if s dot group of 3, once again, 1, 2, 3. If it's null, then I want this to be 1. Okay, that would be the case for like right here. There was no caret on this one. Else, it's s dot group of 3 dot toInt. Okay, and my tuple, I'm going to return c comma p. So what is this val c? Well, it's the coefficient. Once again, there are quite a few possibilities here. If s dot group of 1 is null, well, that means that there was nothing at all for the coefficient. It would be like here. The x was the first thing that was there, in which case the coefficient is a positive 1. Else, if s dot group of 1, so it's not null. Other possibilities that aren't pure ints, so this one would give us -5. Okay, I can do a toInt on that. This one gives us +3. I can call toInt on that. This one gives us a minus sign. I can't call toInt on that. So in this case, if all I get is a minus sign, I want that. Else s dot group of 1 dot toInt. Okay, and I believe that covers all of our bases. Let's run this. Exception in thread main. Maybe it doesn't. Null pointer exception? Nope. Number format exception for the empty string. Oh, indeed. Oh, okay, so it's not coming out as null, it's coming out as empty string. I can fix that easily enough. I had thought I got nulls, but apparently I don't. Which is good, because we should avoid nulls. Now, where do we have number format exception on null? Oh, so we can get either one. Oh, that was not the thing I wanted to click on. I want to click on this one. Group 4 dot toInt. 1, 2, 3, 4. No, this should be if it's not equal to empty string. I go there. Okay, we're going to have to do. So it actually found 1, 4 just fine. It found -1, 3 just fine. It found 3, 2 just fine. And then it ran into a null here, and the null occurred on this line. So is this a situation where group 3 is winding up being null? Yeah, now it found the 5, 1, and now actually, I think I might be. I'm going to go back to nulls, but I had this as an equal instead of a not equal. Now I'm getting number format exceptions. Okay. On null. Line 19. I want to put in a little print line here. Print line. S dot group of 1 plus s dot group of 2 plus I don't actually need 2. I only use 3 and s dot group of 4. Let's see what all of our groups are coming out as. 4 and null. Okay, so that's, oh, and there's let's put commas in here so that you can see things. When things are empty strings, the print statements kind of hide that from us. Great, so we can get empty strings or nulls. So group 1 is coming off as empty string. Group 3 is coming up as the 4. Okay, I like that. There's the problem. Group 1, in this case, is not null, it is empty string, because we recognize this side, but it didn't pull any characters. The null happens, for example, on this OR. If we match the first thing on the OR, the second thing is going to be null, and vice versa. Whereas when we match this side here, the fact that this just winds up matching on the empty string. And there's our difference for how those two are coming out in this case. Okay, so what is happening here? We find empty string, 4, and null. And we do a check here, group 4. If it's not equal to null, we do this. No, this should have been an equal. If it is equal to null, we do that. Otherwise, we go to the other option. And now it doesn't crash at all. And, well, I have these extra printouts in here. 1, 4, minus 1, 3, 3, 2, minus 5, 1, and 4, 0. Okay, and there you go. So if I run that again without our extra printouts, there are the 5 terms that we have, 1, 2, 3, 4, 5, inside of there. So this was an example of using a regular expression to parse a polynomial, and using the groups to pull things out, using the find all in and the match data to give us the match objects we can use as groups. Typically, the way this works, if you are pulling multiple things out of a single string, a single line, you're going to use something like find all in. If you are pulling multiple lines through, for example, a source, and you've called get lines, you'll probably use the pattern match on there instead. But that's it for this video, and we'll come back next time and talk about our parsers.